Good morning and welcome to my first session at Cisco Live this year. I hope you had a nice sleep and had your morning coffee and are ready to go for a long day. My name is Lars Granberg. I work as a technical solutions architect out of Denmark in Copenhagen. And I'm here today to talk about the new era of LTE and 5G, especially the Cisco Catalyst cellular gateways. Let's kick it off. First of all, ask all your questions you want, both verbally here today. I will try to manage the time, but also after the session, I will be monitoring this WebEx space together with actually some of the product guys as well. So if there is questions you want to ask after the show, please do so through the app. A little bit about what we're going through today. The overview of the devices, the use cases, the architecture, how you can manage and monitoring them, and IP addressing and a lot of other technical stuff. Let's kick it off. This is the product line that we have today on the cellular portfolio from a catalyst and routing perspective. So starting on the right side with the PIM modules, both the 4G and the 5G version. And those of you who had to hear about this before is that something new has happened there since last time. Then we have the cellular gateway, which is the main focus for the session today. And last but not least, the new CD113, which is more from a remote worker solution or work from home solution, which was launched last year at Cisco Live in the US. The pluggable modules for the ISR 1K. One brand new thing from December is now that the 5G PIM, this guy here, is now supported on the ISR 1K. So with 17.9.2, you're able to actually install a 5G PIM in the ISR 1121, 1131, and 1161X, and then actually be able to run 5G on that. So that's a new thing since last. Before diving into the technology, I just wanted to try and lay out the history of what we are talking about from an LTE and 5G perspective. So starting in 2011, the first version of LTE came out, which is the category 3 and 4, which gives us roughly the 150 meg, 50 meg upstream and 150 meg downstream from an LTE perspective. Then as time went along, we then got the advanced version, category 6, and then category 18 in 2018. All which gives us more and more bandwidth, more and more capacity. With 5G introduction, we now have the release 15 and 16 from a 3GPP perspective. We now have up to 6.5 gigs of downstream, of course, theoretically, because it's a lot about network and all the other stuff around that. So just to set the stage on where things has coming from. Let's go through the overview of the device. So this is the cellular gateway. It is an external device. You can have a flexible deployment model. Either it can run by PoE or an AC connection. It has rich services with enhanced performance. We have two platforms, the CG418 and we have the CG522. The 418 is the 4G only version and the 522 is the 5G version. They are all running the iOS CG click or cellular gateway operating system. So it's not iOS XE as it was in the beginning. We moved away from that. It is a pass-through device. So today there's no layer 3, layer 4 services. It's not a router. It is a gateway. There's no NAT on it today. And I have put an asterisk there because I will tell you something else a bit later on in the slides. There's no firewall on it. Again, cellular traffic into the device and then IP out to your router or device on the back. So it is a pass-through device as such. Let's look at the specs for a second. So as I said, we have two different versions. They share the common chassis. They share the common software feature set. But there are varieties inside it from a modem perspective. So if we look at the hardware side, it's cellular, it has Ethernet, dual micro SIM. It can do 4x4 MIMO downstream, 2x2 MIMO upstream. It has an auxiliary port, so we can do reverse SSH to a router or reverse console. And we can do hardware crypto as well. And it's supported with third-party devices. So it doesn't really matter what I plug into this device. It could be a laptop, it could be a router, it could be whatever. As long as it has an IP port, IP Ethernet port, it can connect and use this guy as an uplink. On the software side, we have both support for IPv4 and v6. We can do failover between the two SIM slots that is inside of it. We have local web UI now as well, and we can do SSH for remote management and a lot of other stuff that you can look into later on. Sorry. So the CG418, this guy here. It has dual SIM, as I've said. It can be zero-touch provisioned. It can be used for SD-WAN and whatever. It has support for all these bands downstairs, or you can see on the bottom here. The green numbers are the CBRS bands for US, which is the FirstNet responders. And it's mostly common there, and there might be people here in the room that knows more about the LTE bands than I do, but this is what we support from that perspective. And has this Telit modem for the 4G version. We can support external antennas as well. It comes basically with these small antennas that you see here, but we have support for external as well. If we looked at the 5G version, same fixed model. The only thing you can see as a difference is the 4G version has one LED, the 5G version has two. I'll send them around in a second so you can see them as well. Those are clear. So different modem, but the rest of the stuff is the same. So if you look at it from a feature perspective, the auto SIM, so it chooses between the two SIM slots that's in there. You can have failover, so you can have one provider and another. So if you have things that moves, it can switch providers as it goes along. Or if one provider stops serving you because you have run out of data package or something else like that, it will switch automatically to the other one. We can configure APNs. If we need to have private APNs, we can configure that either directly on the box or through VManage. I will show you that in a second. And we can do carrier aggregation, so we can get more bandwidth down to the platform. And last but not least, you can build your own LTE network, the CBRS bands that I talked about before. So I said from in the beginning that it was not a NAT device. With 1710 that's just come out, we changed that a bit because we would like to use the NAT feature to enable SSH from the outside world. So if you have a fixed IP address on your SIM or your LTE device or LTE connection, we can now use that as a management point as well, before you need to go from the internal side of the device. So now we support WAN SSH. We also enabled syslog. And last but not least, we have the local web UI coming back. Those of you who have seen the platform before knows that there was a local web UI on the box when we initially launched it. But that was when we were running iOS XE. And there was a change in the software platform to migrate over to the Cellular Gateway OS instead, which is a more lightweight software, so we can do more features. And the device had a lesser footprint from a software perspective. So the auto SIM carrier selection. You just insert the SIM and power on the device, and then the device will choose for itself which of the SIM cards it should use. This will make it very easy to deploy and very easy to maintain. Carrier aggregation, what is that? Well, it's a matter of how you can bond the channels on the LTE side of the network to get higher bandwidth, higher throughput on your device. So without, it looks like this, we will take one channel and start pushing traffic across that. If we switch to Advanced Pro, where we can enable carrier aggregation, suddenly we can combine multiple channels and therefore utilize the LTE side more. It requires that the provider supports it, and there is enough room on the cell that we connect to. So it can vary a lot depending on where in the world you deploy these devices. If we do it on the 5G side, we suddenly use the 5G as the data path, and we use the 4G as well, so we can combine the two. Because in the 5G version, we both have a 4G modem and a 5G modem. So they can work on both bands at the same time. If we look at our portfolio today, this is what we got. So the two Catalyst cellular gateways, but we also have some sisters and brothers over in the Meraki side that has the same. Stay focused. If you are a Meraki customer today, stay focused on Cisco Mobile World Congress. There might be some news there on the Meraki side. So use case. Why is it important to have such a device? Because we have the PIM modules where we can connect directly to the router. But normally, those devices, the routers, are placed in the dark basements far away from any good cellular coverage. So when that happens, what to do then? Either we can go out and buy some external antenna cables and start trying to drill a hole in that concrete wall and get the signal out. But usually that's not a good path. First of all, it's quite expensive. Secondly, the longer the antenna cables you get, the poorer connection you get, because there's a lot of loss introduced in the antenna cables. So instead, this guy connects from an Ethernet cable, meaning I can connect it up to 100 meters from any point of my network. It doesn't need to be connected directly to the router. I can connect it to a switch far away in the network, and then just have a VLAN trunked all the way down to the router. So when I can connect this guy, and I can then set this far away from the router where we have better connectivity. It comes with an AP mount in the back, meaning that if the architect of the building comes in, we can actually just place it on the ceiling like a normal AP and connect it through PoE. So that's the main use case for the device. If we look at the hardware architecture, on the back end, or on the port side, we have the serial port for console connection. We have the aux port, which we can use for reverse console port, meaning that if our router fails, we can actually console to this device and then go into the router on the console side. We have a reset switch, very important, and then we have on the 4G version, we have the external GPS antenna point as well, so we can pinpoint where is this device. And then last but not least, the two micro SIM slots behind this gate, and then the uplink port. There is a small detail. Here you can see there's a yellow sticker, meaning that this interface doesn't have PoE Plus enabled. So when you order this device, you can choose between PoE option or not. So if it's non-PoE, it's yellow. If it's the PoE version, it's blue, meaning that you can just plug it into a PoE port and connect it or power up the device from there. Last but not least, the out-of-band power, so a normal AC power brick connection. And then we have the 4 SMA connectors on the side of the device for the antennas. As you saw here before, and here as well, the antennas are default the 5G ANTM SMA-D antenna, which is the normal antennas you have seen for many of our LTE devices over the years. And they are optimized for straight or 90 degrees and appropriate for indoor use. We also have an external antenna. This is one of the examples that we have, which is actually a combination antenna that has both Wi-Fi, LTE, and GPS inside itself. So it has these 7 cables coming out, but can be used and drilled into metal boxes and that sort of stuff. Management and monitoring. So as I said, we started out with having CLI access directly to the box when I connected on the internal side of it, so on the Ethernet side of the box. We also have support for now the WAN SSH. There's something here wrong with the slide. Oh, sorry for that. And last but not least, we have the VManage that can manage the cellular gateway, either the router itself or the extension of the router from the VManage UI. We can also separate the two. So if you are a service provider and want to add this as a managed service, you can manage this guy, and then the customer can manage his own devices on the back if you want to do that. So simplified management across all the devices. And now the last graphic's coming out. So good for that. So be aware, you need to run the latest version for the SSH, WAN SSH connection directly to the box. The other thing that we can do through VManage is monitoring the actual box, so the cellular network, how the traffic is, how the connection are, and those sort of stuff. And also, we can do plug and play, meaning that we can send out the device, just let the customer plug in a SIM card, and then the device will show up in VManage by itself. We've also now introduced again, or reintroduced, the local web UI, so you have the chance to actually monitor the device locally through IP. Demo time. So what we have here is a demo of the local web UI. And here you see we can configure the device itself. So here we're looking at the log side. We can also go into the SIM slot, choose the two different SIM slots, and configure the options for that. And last but not least, in a second, we will also show you that we can create the profiles, so you can create the APN profiles if you want to use local APNs or other APNs that your customer or provider provides you, like this. And you can choose between IPv4 and v6, so we support both. And last, users and a local CLI. The CLI never goes away when talking about cellular gateways and Catalyst. So we have access to that as well. So here we will see a chart of the signal strength of the device. And it's my colleague in the US who has created this video. So it will all be US-based data that we looked at here. So a lot of details around both the radio and the cellular side, and of course the network. Very short, very nice demo of that. So IP addressing, how does this actually work? So when the device is turned on and the SIM card is inserted, it will either choose between SIM 0 or 1, depending on where it's connected. Then it starts connecting to the cellular side. So getting access to the cellular network and registering the device there. It will start getting an IP address from the, let's see, here it comes. So that's how it does that. On the 5G version, we actually use both the 4G and the 5G part of the modem. The 4G as a control connection to control and communicate with the tower what is actually being able to be processed. And then we start forwarding data on the 5G data plane as such. There we go. So IP addresses. The device gives out an IP address to the back end of the device. And we do that automatically. So when there's no connectivity on your cellular side, you will see the 192.168.1.1 address on the device, and you will always receive 1.2. It's not supported to add more than one device on the back of the cellular gateway. It's not a router. So it only hand out one IP address. So if someone put in a switch there and thought, well, now I can set all my clients behind, you'll be cheated because it won't be the first device that gets an IP address. The rest will just sit there idling. So one IP address. And we will only accept management traffic at this point because we don't have any access to anything else. The cellular is not up yet. The next thing that will happen is that the cellular device will acquire an IP address from the service provider. In this case, 10.0.0.1. The cellular gateway generates an IP to use as the default gateway and apply that to the bridge network of the LTE address. So suddenly, we will see an IP address change on our client. But that doesn't matter because it's not just normal DHCP. So cellular gateway now service, DHCP server offers the 10.11 address, or 0.11 address, to my client and acts as a gateway itself. The management address remains the same. So 192.168.1.1 will still exist. So if I try to reach that from my client, I can access the web UI if I'm running 1710. So when we are sourcing the WAN traffic, it will be sourced from the service provider offered address and routed dynamically to the generated default address on the device. And that's how we got the connection through to the internet, as shown here. So when the device is up and everything are running, and in this case, we are running with VManage, we get a system IP on the device that we can use and show from that side. And if you show the routing table of the device on the router, it shows like this. If we go into the basic required configuration, this is what we need. It is on the router side in this case, we are configuring the MTU size for 1428. We're running DHCP and negotiation. And that is the minimum requirement from a router perspective to get a DHCP address. So before going into the next demo, I just want to send these around so you can actually see them. We can have the 5G version on this side, and then we have the 4G version on this side. And just pass them around. As long as I get them back before the session is over, I'm all happy. Yeah, a question? Good question. They're working on it, but I have no committed roadmap at this time. So right now, it's only physical SIMs. Any other questions while we are here? Good. Demo. What we are showing here is the automation or automatic onboarding through VManage. So we start on the PNP portal, where we register the device serial number and UUID. So here we are choosing our virtual account. We add the device, serial number, base ID. In this case, I believe it's the CG522. And then choose the controller profile. The controller profile is required, or is automated, applied when you have a VManage instance running already. Just pause the video here. When you buy new devices today, your rep will ask you for your smart account and your virtual account you want that device to land on. And that's from a PNP perspective, meaning that when the device is leaving the factory, those serial numbers and the SUDI ID will be automatically populated. So you can just go into your VManage and synchronize that information and be ready to go. So this is showing how you're doing it manually, but in normal world, this should be done automatically for you, these first steps at least. Let's see if the video will continue. It does, perfect. So now we are in VManage, and now we have the synchronized smart account button. So this is actually where, in the normal case, you will just start your work, because you can just sync your smart account and get your information in. Which also means that your devices can be shipped directly to wherever you need them from Cisco, because you don't need to have it in your hands before deploying it. So now we are building a template for the device. In this case, they want to configure the device for something specifically, so they want to create a profile for it. So inside VManage, you create templates for your device, which can consist of username, passwords, APN information, all that stuff. And that's what we are showing here. So we create a template, choosing the device. You can see there was a lot of other devices in there, as VManage is the management platform for SD-WAN as well. So that's why we have reused it there. So name for the profile, a template name, description, and then in this case we have a system template. We'll use the cellular information here and create a cellular profile for these devices specifically. So if we look here, we are now configuring the basic information with a template name. And in this case, we would like to set the admin password. You can also see that we can set management interface, time zone for locking, all these stuff that is nice to be able to configure from that perspective. let's continue. So down here we have the different selections around SIM. We can set the fabric time, and we can do retries and so on. So now we have set the password. We will save or create the template and then associate it with the device. So let's play the idea that you have ordered hundreds of these devices that you want to populate across your entire sites, all of your sites. In this case, the only thing I know is a serial number. So that's what we are attaching here. We could have variables from host names and other stuff. So we could just have that long list of devices and just say, okay, first device going to this site, put in the variables for that, the second device, and so on. Meaning that, again, I don't need to have the box in my hands to do the final configuration. It will just be connected to the network. It will find a way back to the VManage and then get its configuration from there. So we associate the device. Here you can see we are setting the variables for that device, in this case a host name, the system IP, and the site ID. And then we update the template. And again, Cisco is still a CLI house, so we actually show, you're able to see the CLI that's being pushed, so you can log that for your ITSM tool. You can also click on the config difference. The video doesn't show that, that's why I'm stopping. You can click on the config diff, so if you're making a change after you have deployed it, you can actually see what impact does that change have. Change of host name, change of IP address, or whatever, you can actually log that as well. So VManage is a very powerful tool from that perspective. And when VManage has control over a device, if it's a cellular gateway or an SD-WAN device, it's VManage that owns that stuff. So you can't SSH in and change things. Then it will say, I'm in control of VManage, go over to VManage and make your changes. You can still do CLI troubleshooting from the device, both on the cellular gateway side and on the routers, because you have access to it, but you're not allowed to make any changes besides through VManage. So here you can see the full configuration, and we now say, go ahead and configure that device. So now it's succeeded, and the device is configured with our configuration. And we can then click on our devices and see it's up, or sync pending in this case, because it's not powered on yet. But we can see there that the template has been assigned to the device. So when the device is powered on, it will change and get that configuration out of it. Now we switch gears into the monitoring part. And here you will see just stop the video here. Here we'll have the main overview of the device from a hardware perspective. So you will see the module, the temperature sensors, if there's something like that, CPU, memory, power supply, and so on. Of course, this is a generic page, so therefore some of these values are set as NA because they're not relevant for a cellular gateway. But if it was a router, you will have seen some of that as well. If we go into the graph here, we will now see we're testing a video which goes through the CG. So the client we are looking at here is actually using the CG as uplink, and we can start seeing the traffic that it generates. So showing that the increased bandwidth that we're using are now being shown as the traffic used here. So we have cheated a bit and seen some more. So now we can actually see that the traffic is increasing and how much bandwidth we are actually utilizing on the cellular gateway. While we're seeing these nice film. Another thing that we can do with VManage is there's actually a built-in SSH terminal. So meaning the device is connected, I'm sitting somewhere else, but I have connection to VManage and can then go from there and SSH into the device and do whatever commands that I would like to do, from a show perspective at least, or troubleshooting perspective. So here we are signing in, still have the username password validation, and the next thing will be to do a show cellular network, I believe. So here you see the UI, or sorry, the CLI interface, and now we'll do a show, and I believe it will show us show cellular in a second. So let's pause it there for a second. So what we see here is actually the same information as we saw before on the UI, but here we have the show cellular 1 network, meaning the first interface or the first modem in the device and the network side of that, meaning what information am I receiving on the LTE side. So in this case, we can see that we have a switched network, and I believe you all could also see the provider somewhere, or it's coming in a second. Yeah, it's AT&T, that was. So we can see which network we are connected to in that sense. The next show command shows us a bit more about, let's run it out, cellular. Yeah, radio. So there we'll see the radio settings. How good connectivity do we have? What is the signal loss ratio and those stuff. So seeing how we can, and in this case, which radio are using, in this case we're using LTE, but if it was a 5G network we were connected to, it will have said 5G here as well. Let's see, I think that's the end of the demo, if I remember correctly. Good. Use cases. Any questions so far? Yeah?
What you just showed should be available in VManage, right?
It is in VManage, yes, and it is today. Are you running VManage today yourself?
Yes.
Which version?
2019.
Then you should see all this already.
It's more trustworthy to
True. But it is there. Any other questions? Good. So from a use case perspective, where is this relevant? We talked about before the routers placed inside a basement in somewhere where we don't have cellular connectivity. But other stuff could be where we are having remote offices set up very quickly, where service providers can't supply a line fast enough for your business. It might be that the business comes down and wants to open an office somewhere in the part of the world where you don't have any agreements yet. Well, just send out a cellular gateway with a SIM card inside, and you'll be good to go. It could be where you have things that moves around all the time. Agriculture, that sort of stuff, where you need to have data feedback all the time. Place the device there. Or where you want to have scale in your network as well. If we take the other part of the stuff is offshore industry or trains. We actually have a customer who has deployed hundreds of these guys inside trains to provide customer connectivity along their journey. So sitting in your train, want to work or do Facebook or whatever, the train operators provide you with Wi-Fi connectivity and then backhauls the traffic through cellular gateways. Then the service provider only has to provide limited amount of masts along the route, and then all good. And of course, doing it as a failover for band disruptions. There's other sessions here at Cisco Live running around talking about LTE 450 megahertz as well, which is a low latency or low bandwidth but long reach LTE networks that can provide longer uptimes if a power outage comes. Depending on your networks and your provider networks, especially at least in Denmark, we have an uptime of 4 hours if a power outage occurs. the providers guarantees you that the cellular network will operate for 4 hours after that fact, if you have a mass blackout. With 450 megahertz, they actually provide you up with 8 hours of connectivity because the network's power consumption is a lot slower. So they can actually provide you with longer uptimes using 450 megahertz network instead. But that's for another session, but I just wanted to emphasize that as well. So these are some of the use cases, at least, that we have seen so far. So which carriers are supporting us today? In Europe, it's generic use, so every carrier are supporting it, and it works quite well. In the US, we have different carriers that has validated the device and the different firmware tweaks to them all. And again, you can switch between them automatically from the VManage or in the device. New Zealand, Australia, different providers there, and as well as in Japan. So worldwide coverage, you can use them wherever you want. There's no different SKUs, it's the same SKU all the way. You just switch the firmware in the box. I put in for your resources, for your reference, a ton of links for the relevant documents. So if you want to deploy and learn more, here's where to look. Where are we on time? We are quite well in time. Any other good questions while we're here? Sure.
You said that it's made for when you have no cellular reception. Why don't you put an SFP then? Because you can only reach 100 meters.
So, sorry, please repeat. I said.
You said that it was made for when you have no cellular reception.
Yeah, inside your routers. Yeah.
Shouldn't there be an SFP instead?
Well, you could argue that. True. But normally, you will have a network in the vicinity anyways. So with copper, we have PoE, and SFP just cranks up the price. So that's one of the considerations why we didn't do that. But yeah, you're right. We could have plugged in an SFP and then extended it even further. True. But that was not the case in this case. But you're right.
With the PMP,
Yeah.
you saw 2 different models of 522s. Are there any planned
It's
additional models?
not at this time, as far as I know. So this 522E. Here first?
Can I use like point-to-point VLAN between?
Yes. So if you have a router and then a switched network, you can just create one VLAN that you trunk all the way through. As long as there's only two, the cellular gateway on one end and the router on the other end, then sure. There's no technical issues with doing that. I will come back to you. I will also have this guy.
Go back one slide.
Yes.
So certification in progress, does it mean it won't work at all?
No, it will work. It's just a matter of this, if the service provider wants to tweak the firmware in any direction. So the generic use is available and to use all around the world. It's just a matter of if the service provider is large enough to actually provide certification for it. Sure.
So how does this compare to the ER1101, which is an industrial router who has modules for connectivity like this?
Yes. So the question was, how does the cellular gateway compare to the IR series, so the industrial routers? There's no plans yet for an industrial cellular gateway. This guy is only internal, so it doesn't have any IP. It's IP27 or something like that. So if you are in a harsh environment, you need to go with the PIM module inside the IR1101s. That can be sitting and locating there for now. So this is the 5G PIM that fits into that.
From a functionality perspective,
Same.
quite similar. Because
Exactly.
this with VManage.
Yes.
And,
So this PIM module is what is, it's the same modem as it's inside the VAT box.
so the dual SIM, auto SIM,
Same.
and all functions.
Same. So from a software perspective, all the same functionality. It's just a matter of the form factor.
It's iOS running there, right?
So this guy is not having any software on it because it actually comes in as an interface on the IR case or on the ISR 1K. So this is just a cellular NIM module, you could say. So all the software there is iOS XE. But because this is a standalone device, we need to have some sort of software running on that. So, yeah. I'll just come down, otherwise I can't hear you.
You're not using the gateway with SD-WAN, so you don't have VManage.
Yep.
Can you still use the plug-and-play portal to actually get visibility on it as it comes on?
So the question was, if I don't have SD-WAN and VManage, can I still use the PnP portal for zero-touch provisioning of the device? Right, today the answer is no, you can't. Because the PnP portal, what it only does is it redirects you. So the device comes up, and if it doesn't have any configuration, it will search for the plug-and-play portal and say, here I am, my serial number is this, who owns me, and where should I go? So with the PnP, that's why there is in the PnP portal also was the link to my controller profile, because that's actually what the PnP portal does. My name is 1234. Who owns me? Well, you do. Your VManage is there. Go and talk to that guy, and then get the configuration from there. So without that, we don't have any automation from that perspective.
If the device is managed through VManage, what is the data usage for telemetry and stuff? Because it can be used as a gateway or path filter, and then you
Yeah. So from as far as I know at least, it's not that much because we don't have any BFD session running. So it's a limit. It's very limited in terms of how much traffic we draw from it. From a monitoring perspective, I don't have the real numbers here, but I can put the question in the WebEx space and I will figure out and come back.
Okay. And one more question: is it possible to set up a loopback on the device so it can be accessible in VManage mode, so it can be accessible through the network and not just through VManage?
It will still be able to access it directly on the IP address from the network side. It uses the same interface. So yes.
But
So
it will be on the LAN side, right?
it will be on the LAN side.
But there's the IP path.
Yes, but you still have the 192.168.11 address you can reach.
That will be from the
Routers.
device only,
Yes,
not from the whole network.
correct. There's no support. There is something coming in the next release of the software, as far as I know, to cover that part as well.
Okay.
Good. There was a question here.
Regarding IP addresses.
Yeah.
So if I'm getting static public IP address from ISP,
Yeah.
that means that if I will get my Cisco standard classic router connecting to this gateway, then through the HCP, that means that I will get from the HCP this public IP address that I get
Yes.
from ISP.
Correct.
On my Cisco classic router.
Yes. So the cellular gateway receives the IP address from the service provider through IPCP, and we'll just forward that IP address to the device. So we'll see that as an inline. Sure.
The 192.168 address on the LAN side,
Yeah.
if you do not use VManage, can you make the initial configuration of the cellular gateway from the LAN side?
Yes, you can.
SSH, HTTP?
SSH in the early stages or HTTP when you got to 17.10. Good. Any other questions? Sorry, what? Just behind you first, and then you.
Can the GPS be used as a time source?
Not today. I don't have any information about the roadmap, but there's not a function today. Right now, we'll just use the cellular gateway as the time zone. Thank you. Or the cellular network as the time zone. There was a question down here.
That was an excellent question.
Yes, it was.
So my question is, what is the plan for supporting standalone 5G networks and especially private 5G networks?
With these guys? That's a very good question. I don't have the answer for it. Put it in the chat, and I will come back. You sure?
What about IPv6/48, for example? It's designed to custom network. How is this bridging work?
Well, I'm not an IPv6 expert, so I will try to answer as good as I can. But you will turn on IPv6 on the cellular gateway, and there you can either receive the address from the provider or you can assign your own. So it depends on it depends on your agreement with the provider on how to use your own /48. So the cellular provider needs to do something there as well. But yeah, it's supported. Good. So before we give you some couple of minutes back, there's a ton of other session around 5G and the multi-domain architecture, which this session is a part of. So I put this slide in for a reference. It's also in the deck, so you can find it. There's both cross-integration. There's also something else around 5G as well. Please, please, please fill out your surveys, not just to get the T-shirt, but it's valuable feedback for me as well as a speaker. That's also what actually provides me information if I'm allowed to come back or not. So please, please do. Continue your education. Visit the showcase if you haven't been there already. You will see the devices. You can talk to other guys that knows a lot about it. You can book me for a Meet Engineer if you want to, not just on cellular gateways, but also on routing and SD-WAN. There's also a ton of other very clever guys there. Meet the speaker, which is a new thing this year. So actually today at 17 or 5 o'clock, I'm hosting Meet the Speaker, where we have 20 minutes, 40 minutes together, where you can come and ask all your questions. If you didn't want to ask them here, come by, so you don't have to take the time now. Of course, the session will be available online on the ciscolive.com/on-demand. That's it. Thank you so much for coming.